So you guys could do some quadratics practice, and I'll do a handful of these. I don't know how many, but a handful. I don't have a lot of time this morning. I'm going to start with number 2, and what I notice is all terms are even, which means divisible by 2. So I'm going to pull that 2. If I pull a 2 from 2n squared, I have an n squared left. If I pull it from I think it's a negative 18n, I have a negative 9n left. And if I pull it from 40, I have 20. So this makes it easier to factor because to make an n squared, you got to have an n and an n. Now, what I'm thinking about is factors of 20 that add to negative 9, and that happens to be negative 4 and negative 5. Some kids can factor and some kids can't. It actually hinges on, your multiplication tables for the most part. Kind of stinks if you thought that was stupid when you were in 3rd and 4th grade and didn't want to memorize. It comes back to bite you. Anyways, it is to be solved, so now I'm going to use the zero product property. So n minus 4 is equal to 0, or n minus 5 is equal to 0. So if I'm doing an n minus 4, I add 4 to both sides. If I'm looking at n minus 5, I add 5 to both sides. So n is 4 or n is 5 by the zero product property. 4 is kind of interesting. And there's other ways of doing this, but the big thing I notice on 4 is both terms divisible by 3. So I pull that 3, and I'll be left with x squared minus 25. Now, it might be good for some of y'all to think about this as x squared plus no x minus 25. This is actually what we call a difference of two squares pattern. But what I need factors of 25 that add to nothing. And those happen to be minus 5 and plus 5, because negative 5 times positive 5 is negative 5, and negative 5 plus 5 is nothing. And again, we're still equal to 0. So we're going to use that zero product property. I can type. If I'm looking at x minus 5, I'm going to add 5 to both sides. If I'm looking at x plus 5, I'm going to take away 5 from both sides. So x is 5 or x is negative 5. All right, number 5, actually let's do 6. Now, in order to solve by factoring and the zero product property, you must be set equal to 0. So when I do 6, I'm going to have to move some stuff around. And I'm going to have to put it in the right form, too. I got to have the x squareds first. I already have a minus x. And I'm going to jump this negative 7x over, which makes it positive. I have a minus 6. And I'm going to jump that negative 6 over, which makes it positive. I'm going to combine my like terms. Negative x plus 7x is positive 6x, and the 6's cancel. Now, how does this factor? Well, this factors by pulling out the common factor, and both terms possess x. That's what I'm looking at, and that's what I notice. Sorry about my voice. If I pull an x from x squared, there's an x. If I pull it from a 6, there's a 6 left. And now I'm going to use the zero product property. So what I have is I have x equals 0, or x plus 6 is a 0. And the only one I have to do any work on is that one. Subtract 6 from both sides, and done. All right, moving forward. Let's do one of these where a is not 1, and these won't be able to 9 or 10. You can't pull anything because they're all, one of them's odd and the rest are even or so forth. But we're going to take number 10 and we're going to shift everything left because we want to be able to use the zero product property. And I can't pull anything from all three pieces, but I know it takes a 3n and an n to make 3n squared. And factors of 8 are probably going to be 4 and 2. But I could be wrong on that one. It's actually going to be 8 and 1 looking at it. think about why I put that way. All right, like you should literally pause the video and be like, why did Milbrath do it that way? Because this is how it works when you check by foiling. Because you have a positive 3n, take away 8n, which is negative 5n. And now we're going to use that ZPP. So 3n minus 8 is 0, or n plus 1 is 0. I'm going to add 8 to both sides, divide by 3. I'm not going to be pushing buttons in a calculator because I don't want the decimal. Or, this one's simple, subtract 1 from both sides. Ta-da! There's only 2 of these on here. This is solve each equation by taking square roots. 11's probably the hardest one. And if you shifted everything left, you'd end up with something that doesn't factor. So we're actually not going to use zero product property. Notice it doesn't talk about factoring, and that means we're not going to use zero product property. We're going to add 8 to both sides, and that's going to give me a negative 80. We're going to divide out the negative 5, and I believe 80 divided by 5 is 16. And now what we're going to do is we're going to counteract squaring by taking the square root. And don't forget, when you take the square root of something, you have to include the plus or minus. I don't think this software has the plus or minus symbol. Be cool if it did. Oh, it does. Cool. Plus or minus. But for some reason, I can't press it. Anyways, let's just do it this way. N is negative 4 or N is positive 4. What's going to kill me here is this is how you guys are going to write it because you're blindly copying. Use the plus or minus symbol, kids. That's what it's for. I just didn't have access to it. I don't know why it wasn't working. This is what I taught you all yesterday, completing the square. So let's talk about your steps for completing the square. You're supposed to, first step is to move or divide. Divide all terms by A if A is not 1. And on all these it is. Second step is to move any constants to the right-hand side. Step 3 is to find half of B, square it, and add to both sides. Step 4 is to factor the left-hand side as a perfect square. Step 5 is to counteract squaring. And the last one here is to counteract plus or minus, addition or subtraction. I'm only going to do one of these. I have no idea which one's the hardest one. So let's look at 20. I'm not going to type this one out. The A value here is 1, so I can go straight to step 2. I'll move that 28 over. A 9 minus 28 should be negative 19. I know that B is 20, so I'm going to take half of that, and I'm going to get a 10. I'm going to square it, and I'm going to get 100, and I'm going to add that to both sides. Negative 19 plus 100 is 81. Now, the left-hand side factors of 100 happen to be 10 and 10, and 10 and 10 add to 20. So it's x plus 10 twice. And notice when I found half of B, I automatically have what goes there. It's just how this works. The opposite of squaring is to take the square root, because the square root has an understood 2. The square root of 81 is either positive or negative 9. You have to include the plus or minus symbol because we have 2 answers. And here we get x plus 10 because the square and the square root cancel each other out. The next step would be to counteract this addition right here. So x is negative 10 plus or minus 9. And then do the math. Negative 10 plus 9 is negative 1. Negative 10 minus 9 is negative 19. And these are really, really easy complete the square problems. So hopefully you won't have any problem with them. Truth is, every one of them probably factors, but you're not supposed to be doing factoring today now, are you? This says solve by completing the square. So there's that. Have fun with that.